Welcome to Biography Zone. Dive into the captivating lives of the world's most famous and influential figures. Here, we explore the extraordinary journeys of renowned personalities, shedding light on their achievements, challenges, and legacies. Each video offers an in-depth look at the stories that have shaped history and inspired millions. Whether it's groundbreaking scientists, visionary leaders, celebrated artists, or iconic athletes, Biography Zone brings you closer to the people who have changed our world. Subscribe now and embark on a fascinating journey through the lives of the world's most remarkable individuals. Niels Bohr, a Danish physicist, was born on October 7, 1885, in Copenhagen, Denmark, to Christian Bohr, a professor of physiology, and Ellen Adler Bohr. Growing up in a highly educated and intellectually stimulating environment, Niels Bohr's fascination with science began at an early age. He attended Latin School and later enrolled at the University of Copenhagen in 1903 to study physics. During his university years, Bohr was influenced by prominent physicists such as J.J. Thomson and Ernest Rutherford. In 1909, he received his master's degree in physics from the University of Copenhagen and went on to earn his doctorate in 1911 with a dissertation on the electron theory of metals. This groundbreaking work laid the foundation for his future contributions to quantum mechanics. In 1912, Bohr married Margrethe Mathilde Lund, with whom he had 6 sons. Their marriage provided him with unwavering support throughout his career. After completing his doctorate, Bohr traveled to England, where he worked with J.J. Thomson at the Cavendish Laboratory in Cambridge. During this time, he was exposed to the latest developments in atomic physics, which would shape his own research interests. In 1913, Bohr proposed his revolutionary model of the atom, known as the Bohr model, which incorporated the principles of quantum mechanics to explain the behavior of electrons within the atom. This model, based on the idea of quantized energy levels, successfully explained the spectral lines of hydrogen and provided a framework for understanding atomic structure. Bohr's work on the structure of the atom gained widespread recognition, and in 1916, he was appointed as a professor of theoretical physics at the University of Copenhagen. Over the next few years, he continued to refine his atomic model and collaborate with other physicists, including Albert Einstein and Max Planck, on the emerging field of quantum mechanics. In 1922, Bohr was awarded the Nobel Prize in Physics for his contributions to the understanding of atomic structure and quantum theory. The prize money allowed him to establish the Institute of Theoretical Physics in Copenhagen, which became a leading center for research in theoretical physics. Throughout the 1920s and 1930s, Bohr played a central role in the development of quantum mechanics, particularly through his work on complementarity and the Copenhagen interpretation. He emphasized the probabilistic nature of quantum phenomena and the limitations of classical physics in describing the behavior of subatomic particles. As the threat of Nazism loomed over Europe, Bohr became increasingly concerned about the rise of fascism and its implications for scientific freedom. In 1943, he fled to the United States, where he joined the Manhattan Project, the secret effort to develop the atomic bomb. Despite his reservations about nuclear weapons, Bohr believed that scientific knowledge should be used for the benefit of humanity and contributed to the project's theoretical work. After the war, Bohr became an advocate for international cooperation in science and a vocal proponent of nuclear disarmament. He played a key role in the establishment of the United Nations International Atomic Energy Agency (IAEA), and campaigned for the peaceful use of atomic energy. In his later years, Bohr continued to work on theoretical physics and mentor younger scientists. He passed away on November 18, 1962, in Copenhagen, Denmark, leaving behind a legacy of groundbreaking contributions to the field of quantum mechanics and atomic physics. Niels Bohr's insights into the nature of the atom revolutionized our understanding of the physical world and laid the groundwork for many technological advancements in the 20th century.